Unmute. All right, we should be good. I'm gonna check things real quick. Video settings, just to make sure. Video's good, audio, check, check, roger, over. Here we go. All right, so section 1.2, factoring with expressions. So we're gonna do that first, and then we're gonna transition to looking at equations. And really the only difference is, of course, the equations have an equal side and two sides. But once we learn to factor, then we can start solving equations. And it comes down to this. If you remember from Algebra 2, this is where it's all leading. If you have like two things or even three things that are all multiplied together and they equal 0, right? 0 is unique. It's called the zero product property. What does that mean? That means either A can equal 0 or B can equal 0 or C can equal 0. Yeah, it only works with 0. One of them or all three of them or two of them have to be 0. That only works with 0. If that was equal to 1, you couldn't say that any of them had to be a 1. It only works with 0. So that's why we want to factor. Okay, that's why factoring is so important. Now, factoring is essentially going backwards. It's like FOIL in reverse. And sometimes going backwards is just a little bit more challenging, right? Like try driving home that way this afternoon, right? Backwards, a little more challenging. Actually, don't do that. That's probably not safe. Unless you're on a closed circuit, okay? Then you can try it. All right, so let's look at, first of all, again, just what is it to be a mathematical expression? We've seen that in 1.1. Mathematical expressions are just collections of numbers, variables, grouping symbols, and operational symbols, okay? So all of these accent points are all mathematical expressions, like 5, 2x, 3x to the fourth minus 1. And then you got on the very bottom there your quadratic trinomial. The one right above that, though, that looks pretty ugly, doesn't it? And a lot of that stuff right now doesn't really mean much to you. But by the end of this year, you will understand what all that means. We are going to be studying sinusoidal functions. You might recognize that a little bit from geometry, right? SOHCAHTOA, there's sine. We have ln of x, which is the natural log function of x. And then we have the exponential function with base e. E is an irrational number, much like pi, which you recognize there on the very end. So that is another mathematical expression. There's no equal sign in it, okay? So that's the first thing we clarified, the difference between an expression and an equation. Terms, again, we've had this. Terms are separated by plus or minus signs. So in that ugly expression up above, we have 4 terms. 4 terms. Factors are separated by multiplication or division symbols, okay? So now in each of those terms, you can see we have that many factors. Now let me kind of point something out here. If you notice up on here, we have an x minus 1. That's still counting as part of the second term. It's not its own term. This is what we call a factor group, okay? This is a factor group. And it's part of the second term. So I think there was a question on one of the homework assignments where, let's just say like this first term, it was to the 3rd power, and you had to distribute the exponent to multiple things. If you do that, you have to consider the entire numerator, 4 sine of x plus 1. You have to think of that as an entire group. You can't distribute the 3 to each term. Because if you remember, one of the things that does not work, we had this in that second column, a plus b to the n is not equal to a to the n plus b to the n. It doesn't work, okay? So there was a homework problem. So if that helps you on the homework problem, that's great. So anyway, you can have factors that are more than just a single number and more than just a power of x. They can be expressions, like that whole thing is one factor, okay, that consists of 2 terms. All right, so example 1, we might get to example 2 today. There's a lot to review here. If you are an ace at factoring, that's great. Maybe you'll just be a little bit bored here, but you'll refine your skills. If factoring is a little bit challenging for you, I'll teach you different ways to do it, okay? So we want to factor each of the following expressions, first of all, completely into linear or irreducible prime factors. First thing you have to understand is what the instructions are asking, right? So what does it mean to be a linear factor? Well, a linear factor is of the form ax plus b. And why would we call that a linear factor? Very good. It's not because I wrote it in a straight line. It's because the graph is a slanted line. Not a horizontal line, a slanted line. Y'all probably remember it better as mx plus b instead of ax plus b. Where m is the slope, b is the y-intercept, same thing. So a linear factor is always an x to the first. That's how you can spot it when it's not graphed. It's an ax to the first. The b could be 0, the a cannot. Okay, so you have to have, it could be just 1, but it's an x to the first. Or irreducible prime factors. So an irreducible prime factor, an example would be like x squared plus 4. That's a quadratic factor because it's x squared, but it's irreducible. It doesn't factor, okay, because it's plus 4. Now, if it were x squared minus 4, as we'll see, that is a difference of 2 squares. That one will factor, but the sum of 2 squares does not. Okay, so not everything can be written down in terms of linear factors. There is a way to factor x squared plus 4, but it requires imaginary numbers. And remember, the default number group that we're working with this year is the real numbers. Okay, so here we go. Example 1a. You want to always look before you leap, right? You want to leap off the diving board and then look and be like, crap, there's no water in the pool, right? I should have looked before I leapt. You want to size up the problem. We're trying to factor it. So for something like this, the first thing you should do is what? What do you think? To standardize the procedure, we can check to make sure it's written in a specific order. Yeah, so let's just talk about how you can classify these. These are polynomials, and you learned in Algebra 2 that you could classify them by degree. This would be a degree 2 polynomial, also known as a quadratic. So that's going to be the largest exponent on an x. It doesn't always have to be listed first, because addition is commutative. It could be at the back. But you look for the largest exponent on the x, and you can classify it by its degree. We call that the degree. So this is degree 2. We call them quadratics. You can also classify them by the number of terms. How many terms do we see here? Terms are separated by plus or minus signs. So we have 3. There's 3 terms, right? So you could also call this a trinomial. I think after tri, you just called it like a 4-term polynomial. But we had monomials, which are 1 term, binomials, which are 2, trinomials, which are 3. So this is a quadratic trinomial, right? Quadratic trinomial. It is written in descending order. So that's a 2, a 1 on the x to the first. That's your linear term. And then 10 is your constant term. It's really x to the 0. So if you look at the powers of x, 2, 1, 0, blast off, whatever. All right, so you take inventory, you make sure it's written in descending order. All right, now these are the easy types to factor. If I give you one, you can pretty much rest assured it's going to factor. It has what we call a leading coefficient of 1. The leading coefficient is always associated with the largest exponent. Okay, this is the leading coefficient. It's not necessarily in front, right? Again, if that x squared were written at the back, 1 would still be the leading coefficient because it's tied to the largest exponent. Whenever you have these types with a leading coefficient of 1, it's going to be pretty easy. So here's what I would do. I would kind of give myself the receptacles, which are the parentheses into which I put my little linear factors. And you'll see I do it like this every time. If you don't have a shelf, it's hard to put stuff on a shelf. So always build the shelf or the space first. Now, this is going to be an x, and that's going to be an x, right? We're unfoiling this essentially. And of course, you'll learn then, maybe target product, target sum. I don't know if you called it that. 10 was your target product, and -7 was your target sum. So you were looking for 2 numbers that multiplied to give you 10 that added up to -7. -2 and -5. Very good. And now what you could do is quickly mentally check the FOIL, first outer, inner, last, right? You get x squared in the front, that's good. Your last, if you want to check that next, that's -2 times -5, it's +10. And then you just check the sum of the inside and outside. So it's a -2x on the inside, a -5x on the outside, that gives you -7x. So that's it. And of course, it could also be x minus 5 times x minus 2. Either way, because multiplication is whatative. Where you can like commutative, right? So like you commute from home to here every day. So y'all are commuters. You go back and forth, you switch sides, right? At home, at school, at home, at school. So that's commutative property. Flip it around. All right, so that was pretty easy, right? Yeah, that's pretty easy. They don't get much easier than that, okay? So let's look at letter B. This is a quadratic, degree 2, binomial, right? 2 terms, okay? So does this factor? What would it factor into? X plus 4, X minus 4, okay? You want to get in the habit of checking yourself before you wreck yourself, right? It's easy to check yourself. All you have to do is refoil it, yeah? So if I did FOIL, first would be x squared, the outer would be negative 4x, the inner would be positive 4x, and the last would be negative 16. Now the nice thing about x plus 4, x minus 4 is because your inner terms here are opposite signs. So when you add them together, they do what? Can't cancel. Yeah, we got to learn the terminology. Things cancel to give you 0, things divide out to give you 1. These cancel, and you're left with x squared minus 16. And you compare it to what you started with, and you're like, no, maybe Mr. Corpy won't notice, right? Or you just put a plus there. Is that how things work? No. So this, what we ended up with, is a difference of squares, okay? And it would factor into x plus 4, x minus 4, but this one is a sum of squares. And does it factor? No. Okay, this is what we call, again, an irreducible prime factor. Irreducible prime factor. So rather than erase all of that work, since it didn't work, you have correctly found one way that doesn't work, okay? So it's not like you're wrong. You get in the habit of checking work, and now you successfully found one way that doesn't work. So what you do over here is you just say prime, right? Amazon got permission from the Federal Aviation Association of American Drones or whatever to start delivering package by way of drone. So that's going to be happening real soon. That's pretty cool. Okay. All right. It's prime. Letter C. Oh boy, letter C. Okay. Step 1. What do we do? You can pull out a greatest common factor, and that's the first rule of factoring. Okay, let's write that up here. Rules for factoring. Rules number 1, the first rule of factoring is to pull out their GCF, the greatest common factor. But there's actually a step before that, right? So that would be like eating. But before we eat, we have to prepare the food and set the table. Who sets the table and eats at the table anymore, right? But you have to prepare. So that's what we have to do first before we start factoring, or I would recommend that. This is a what? Linear trinomial? Or is it quadratic, degree 2, or is it degree 3? Remember, the degree is always the exponent on the largest variable. That's 3, okay? So it's a cubic trinomial. Degree 3 is cubic, 3 terms trinomial. Negative 4 is your leading coefficient. And notice it's not in the front, but we still call it the leading coefficient because it's associated with the variable with the largest degree. So what I would do before I start factoring is write it in descending order of degree. So negative 4x cubed, minus 4x squared, and then plus 24x. A little housekeeping, right? And again, every line is equivalent to the one above and below. Now we can pull out the GCF. So when you do that, I would look for numbers first. What number do they all have in common? 4. And then x-wise, they all have an x. So now it's times. Now here's one other consideration, and I would do this every time. If you ever have a leading coefficient that happens to be a negative number, whether it's negative 4 or negative 1, you're going to want to factor it out as well, because it's a lot more difficult to factor what's left over if you have a negative number in the front. So factor out that negative. Now, when we factor out, we're dividing out, okay? But we're not getting rid of what we're dividing out. We're putting it out front. So what are we left with in the first term? An x squared. Yeah. Now, again, here's what we're doing off to the side. We're dividing out. You won't probably have to do this, but it's good to see what's really happening. It's what we started with, that first term, and we're dividing out what we're factoring out. So you do that, those divide out, X cubed divided by X is X squared, and that's what goes in there. That's the quotient, okay? And you can real quickly check. If you distribute it back in there, what do you get? You get negative 4X cubed, right? So again, get in the habit of checking yourself. Math is one of those things you can actually account for things as you go. Then we get a plus X, the signs all change, and a minus 6. Boom. Are we done? We did something. Are we done? Do we walk away? No, we persist, right? Until it's irreducible or they're all linear. So now we focus on what this is, and that is, again, a quadratic trinomial. And so does that factor anymore? Well, let's see. I'm going to put my receptacles in place. The first one would have to be an X and an X. And now, of course, the target sum is negative 6. I'm sorry, the target product is negative 6, and the target sum is implied to be a 1. So are there two numbers that multiply to give you negative 6 that add up to positive 1? Yep, 3 and negative 2. So either plus 3 minus 2, or you could write it as negative 4x, x minus 2, x plus 3. Either one of those. Now it's completely factored. Those are all linear factors. Now, a little bit of just kind of how we list things. Those two factors on the back end, really, when you're writing it down, you could put them in either order. You can really put all of these factors in any order. But what we customarily do is we put the numbers in the front. And then if we have just a power of x, we put that next because it doesn't need parentheses. And then any other factor after that, we list however we want. But look at this. Is this equivalent? Multiplication is associative. So can I write that as x minus 2 times negative 4 times x plus 3 times x? Is that the same? Look carefully. That's not the same. You might intend it to be the same, but there's a flaw that you have there. Look at the negative 4. If you were to just happen upon that and read it from left to right, you would say the quantity x minus 2 minus 4 times that. You've turned it into a subtraction problem. So if you're going to put that negative 4 in the middle, you need to put parentheses around it. Now it's a factor. Now it's correct. Okay? So there's always that burden of you to clearly communicate. So that's why it's better just to pull numbers out front and then x's, and then the other factors can go in any order. So be careful, right? Be deliberate as well. Okay, cool. Any questions so far? Pretty easy review, right? Algebra 2, maybe even Algebra 1. All right, letter D, letter D. You do it. You do it by yourself. Okay, take like 2 minutes. Factor that one. UV. All right, I did it one way, and I just was feeling that way. Did anyone get the answer I got on the left? I put question marks at the end because it kind of felt naughty a little bit. I'm not sure if it was right. Anyone get that answer? Now, sometimes depending on your mood, you might see a problem differently than you would at a different time. And for sure, you might see it differently than your friend. I'm guessing most of y'all probably started the way I did on the right. In this case, you have a u cubed and a v cubed. So we have two variables now, and they're both cubed. So we can't qualify this as a function of one variable. So writing it in descending order, you just get to choose which one you want to have. So because it's written already with the positive term in the front and the negative in the middle, I'd probably leave it like that. Because when I rewrote it on line 2 on the left, that puts the negative term out front. And who likes to lead with the negative? Nobody, right? You meet someone for the first time and you lead with the negative. It's like, boom, you don't get a second chance. There's also a higher burden of notation when you have a negative out front. So let's just say, okay, we'll make the second term negative. It's already there. We look for a common factor, and it's u times v. So we pull the uv out, and we get uv times quantity, u squared minus v squared. And again, if you're not sure that's correct, what can you do mentally quickly in your head? Check. Redistribute. Do you get what's above? And you're like, yeah, cooking with oil. Hot oil, right? 350 degrees. And now we're done, right? Or no? No. Sisu, baby. We keep going until we can't go anymore. uv looks good. Those are both linear, but u squared minus v squared, I think we've seen that already. That is a difference of squares. Yes? So that's what we call a special product. Okay? Like Clorox wipes. It's a very special product, and rarities these days to get them at the grocery store. This is a special math product, meaning something that's multiplied. So if you remember, the way you factor a difference of squares is you take the square root of the first one, you take the square root of the second one, and then one of those is plus and one of those is minus. Okay? And we've already seen when we tried the x squared plus 16 that the middle term goes away because they're opposite signs on the same. So they cancel. You get a uv on the inside and a minus uv on the outside. They don't double, they cancel. Now, these two guys right here, u plus v, u's minus v, these guys have a special name in relation to each other. You know what it is? Are they brothers? Cousins? Friends? Let's see. I'm gonna reveal a letter at a time, kind of like Vanna White in the speed round. Not quite. What? I heard it. No, that's an English term, but that's close. Conjugates, right? Conjunction, junction, what's your function? You ever watch those? Schoolhouse Rocks? Good stuff. These are called whatchagites? Conjugates. Conjugates, okay? Conjugates only differ by the middle sign. That's it. One's plus, one's minus. That's it. They're conjugates of each other. So here's what you need to remember. A difference of squares always factors into the product of two whatchagites? Conjugates. And the product of two conjugates always becomes a difference of squares, okay? Back and forth, back and forth. Now, we're done. That looks like the right answer. Did y'all get that? Of course, you could have u minus v first and u plus v second. Now, is that equivalent to my bottom line on the left? Are those the same? They look different, but are they equivalent to each other? Why is that important? Well, on a free response or a short answer, I would take either one of those. But on a multiple choice question, I may actually have an answer choice that's not the one on the right that you normally get. And you have to search for it and see which one's equivalent. That forces you to play around a little bit more. I think it is equivalent, okay? Watch, we'll prove it. If I take this -1 factor that's out front, I can distribute it to either one of those factors. So let's go ahead and distribute it into the third factor. If I distribute that -1 to that factor, it becomes -v plus u. Would you agree? It changes both signs, okay? And then I have v plus u at the end. So all I did is I changed those signs. Well, addition is commutative, isn't it? So I can flip the terms around. So -v plus u is the same as u minus v, and v plus u is the same as u plus v. Are those the same? Yeah, but for the second two factors are commuted, it's exactly the same. So they are equivalent. Neato. Neato mosquito. All right, a lot of insight here, right? We're just like, we're not just doing stuff and walking away. We're analyzing it. We're like gleaning all the wisdom we can from every problem. It's like the Indians, you know, they used every single part of the buffalo, right? And nothing went to waste. They even like cooked the hooves and ate it like jerky. I made that up. I'm sure they did something with it, right? Ground it into some kind of like medicinal thing. That's what we're doing. All right, any other comments about this problem? Or did we use up the whole buffalo? I think we used up the whole buffalo, yeah. Okay, letter E. Okay, so what do you notice about this one? What's the degree? 3, so it's a cubic and trinomial, good. Is it written in descending order? Yes, okay. So we don't have to like housekeep or rearrange. It's like we walked into a restaurant and the table's already set. So the first rule of factoring, never not the first rule of factoring, is to what? Google it? No. Factor out the greatest common factor. So what number do all three terms have in common? 2. How many x's do they all have in common? 1. Do we want to pull out a negative here? No. Can we? Can we? Yes, you could factor out a -1 if you want to. It's going to make all three terms negative, though. So, no, we don't have to. Okay, and I wouldn't. But had this 18 been a negative number, I would have factored out a negative as well. You always want your leading term coefficient to be positive, okay? Now, we put parentheses, and we go through what's left in the first term. 9x squared. Orale, the second term, 6x plus 6x. And the last term, 1 or 0? Or 0? Are you sure? Okay, okay. All right, good. I want to show you something because this is a common mistake. I put an asterisk, so if you want to write this down as things not to do, in haste, students do this. They factor out the 2x or whatever it is, and when it's entirely gone, like in the second one, we pulled out a 2x, instead of putting a +1, they just think it's a +0, and now they have two terms. So remember, this is the distributive property in reverse, yes? When you factor something out, you're undistributing the 2x. So imagine that there were 3 Walmart stores, okay? 3 of them. And they delivered a gas grill, you know, and now there's a recall on those gas grills. If you go back into, drug screen looks like about to happen. I don't know. Was he trying to come in here or was he checking my door? Is there a bad guy? Did y'all see a guy out there? Is he gone already? Okay, all right, good. I guess he saw the math and ran. Let's say you distribute a gas grill to every store, and now there's a recall. You have to go back in and take that gas grill back out of every store. But when you do that, if there's 3 stores to begin with, do you still have 3 stores to end with if you take a gas grill out? Yes, yes. You don't take the entire other store. So if you start with 3 terms, you should end up with 3 terms. Again, if you mentally check by redistributing, you'll catch that error. So that's a common error alert. Don't do that, okay? So that is correct. You're dividing out. All right, now we're done or no? No, we try some more. So the 2x is good, it's linear, but look at this, 9x squared plus 6x plus 1. So this is important. Y'all remember factoring trinomials when the leading coefficient is not 1? They are more fun than the other types, okay? Now, there's a lot of different ways you can go about factoring these. I learned to do this by guess and check. In the Rio Grande Valley, Weslaco, Texas, 7 miles from the border. It was hot. There was no air conditioning. The windows were open. It was a citrus town. Fruit flies were all over the face. As you're trying to work, sweat is dripping on your paper. Man, it was hard to concentrate. But I learned to factor these by guess and check. That's how my teacher taught it. And I could do these pretty quickly by guess and check. But some of y'all might have learned like a diamond method or there's like a castle method. But if you struggle with these, I'm going to teach you right now a way that you could systematically do it every single time, okay? So here's the problem if you do guess and check. Because the leading coefficient is not a 1, we're looking for combinations of factors of 9 and 1. That's how FOIL works. Combinations of factors of 9 and 1 that add up to 6. Now, in this case, you could probably do it by guess and check real easily because 1 is prime. It has to be a 1-1 combo. But 9 could be a 9-1 combo or a 3-3 combo. And so you'd have to do trial and error. Here's an easy way to do it. Get your target product first. It's always going to be the product of the leading coefficient and the constant. So your target product is 9 times 1, which is 9. Your target sum is always the linear coefficient. So in this case, it's 6, always. Okay, target product, target sum. By multiplying the first and last together, instead of looking for a combination of 2 numbers, you're looking for just a combination of the 1 number again, okay? So now come back over here. We made the problem smaller. We could tackle this small problem. What are some factors of 9 that add up to 6? 3 and 3. 9 is 3 times 3, and that's the same as 3 plus 3. So here's the insight. This is called splitting the middle term. And you may have learned this. It's bona fide math. It's not magic or wizardry. We're going to take the 6 that's right here, the 6x, and we're going to rewrite it as 3x plus 3x, okay? So the only thing you have to be really diligent about here is the grouping symbols, okay? 9x squared plus 3x plus 3x plus the 1, close it. So just double check. Is it still equivalent to the line above it? What's 3x plus 3x? 6x. It looks good. Okay, now what we do is we factor by grouping. You might have heard that. Factor by grouping. And this is what you do when you have 4 terms. So inside the parentheses, I'm going to group the first 2 together. I'm adding more parentheses. And because this is a plus sign, that's nice. I can actually put a grouping symbol between the plus sign and the 3. Okay? If that's a negative, we got to be extra careful. So this is just the associative property of addition. I'm associating the first 2 terms together, and I'm associating the last 2 together. It works. Okay? So what we do now is we pull out a common factor. So we're going to have the outer parentheses, and then inside, what is common in 9x squared and 3x? 3x. So we're going to put a 3x in a parenthesis, and that leaves us a 3x plus 1. Boom. Okay? Now we move on to the next one, plus. Is there anything common in 3x plus 1? No. So what could we factor out? Really, we could just put a 1 there. It's already prime. So we'll put a 1 times 3x plus 1. That 1 is going to be helpful, even though it's not needed, because 1 times anything is itself. It's helpful, okay? Does everyone see what I did? I factored out from the 2 terms. Now, the 2x is on the outside. He's kind of aloof to what's going on the inside. He's not real sure. But here's why this works. I now have 2 factors. And what's common in both of them? The 3x plus 1. You can have common factors that are more than just numbers and more than just x's. They can be functions, okay? So here's what we do. We're going to factor out the 3x plus 1. So you can actually kind of drop the extra set of parentheses. What am I left with in the first term when I get rid of the highlighted piece? 3x. Plus, what am I left with in the second one when I factor out the highlighted piece? A 1. See, that's why it's useful to have a 1 there. And we've done it. Okay? Now, if you want to check, here's what you could do. This is kind of cool little activity. If you take this entire quantity and distribute it, you'll get the line above, won't you? I keep it as a group in parentheses. That times 3x, boom. That times 1, boom. So notice we were able to eliminate 1 set of parentheses. And now it's completely factored. We have 3 linear factors. But, oh, wait, there's more. Mathematicians like to shorthand things, right? So what could we do since there's 2 of those factors? 3x plus 1 squared. When the bases are the same, whether they're numbers or variables or functions, you add the exponents. So that's 3x plus 1, quantity squared. Boom. And that's about as pretty as it gets. Number in front, factor of x next, and then your linear factor squared. Now, can you get there more quickly? Sure. You do not have to do the factor by grouping. If you know how to factor these, you can go straight from here to here. I'm okay with that. 9x squared plus 6x plus 1 turns out to be what we call a perfect square trinomial. It's a perfect square trinomial. It factors into a binomial square. Okay? But if you need to show all that middle stuff, that's great. Okay? Notice I did my work off to the side, and then I brought it back into the project so that every line that you see on the left is equivalent to the line above and below it, okay? In honor of National Skyscraper Day, you could essentially say that we're building skyscrapers, okay? Here's the windows up here, right? The observation deck. Nice. Comments? Questions? Quotes? Quits? Concerns? Good clean jokes? Always. Okay. Let's go to my repository of dad jokes. We'll just take like a little brief intermission here. There's a mysterious crime spree. I don't know if you saw. There's a mysterious crime spree going on in the local IKEA over there at the forum. There's a crime spree going on, but the cops are having a hard time putting all the pieces together. That reminds me of another cop joke, right? Someone broke into the police station last night. They stole all the toilet seats in the police bathroom. Who does that, right? And as of now, the police have nothing to go on. Potty jokes. There you go. Why is Peter Pan always flying? Because he never lands. There you go. There you go. Hey, I gave up in honor of Rosa Parks Day a little while back. I was on the bus the other day, public transportation, and I gave up my seat to a blind person, right? Pretty nice of me to do. And that's kind of how I lost my job as the bus driver. Oh my goodness. Oh my goodness. That one was harsh. Yikes. Yes. Oh. Okay, that's a good one. That's a good one. I gotta remember that one. Yeah. All right, letter F. Letter F. Transitioning back into math, right? Do this one on your own. Okay. Shit zoo. Do this one on your own. Factor it completely. It is nice with vulnerability because you can use different colors to show different layers of grouping, highlight things. Pretty cool. I'll give you another minute to look at it. First thing I'm noticing is it is a degree 2, x squared. It happens to be in the front, but remember, it doesn't always have to be. And it's a trinomial. It's 3 terms. It's not written in descending order. So if you want your first step to be to set the table, essentially, right? Write it in descending order of degree, then pull out a common factor. You can pull out a common factor first and then write what's left in descending order of degree. In fact, you could go straight from that line to this line. If you're that good, you can do that. I'm going to pull out a 2 and write it in descending order at the same time. That's fine. But remember, the more steps you do from one line to the next, there's 2 things that can happen. Number 1, you can make careless mistakes that way. Easy to make careless mistakes. And remember, you're not effectively or as effectively communicating how you're doing that. So when in doubt, don't leave it out. All right, so now in the inside again, we have a quadratic trinomial with the leading coefficient that's not a 1. So again, trial and error here might work, but I'm going to go ahead and do target product, target sum one more time, and I'm going to do it a little more quickly. Your target product is -12. Your target sum is -4. So now instead of looking for, this is your target sum. Right? The target sum is always just the middle term. Always just the middle term. Yeah. Your target product is always the first and last when it's in descending order. And the target sum is always just the linear coefficient. Okay? Yeah. Now, again, trial and error here would work pretty quickly because 3 is prime. There's only one way to factor 3. It's got to be a 3 and a 1. But 4 could be a 4-1 or a 1-4 or a 2-2. So right there, you already got like 6 different combos to try. So what are some numbers then that multiply to give you -12 that also add up to give you -4? 6 and -2? -6 and +2. -6 plus 2. There you go. Or 2 minus 6, right? Is that the same? Yeah, -6 plus 2 or 2 minus 6. So we're actually going to work this with 2 different ways because depending on how you split the middle term. So let's go down this branch. The 2 is still out front. We still have to write it. We get 4x squared. If you do the first way we had it, we're going to have -6x plus 2x and then -3. Okay, so notice what we did. We just split the middle term. Now we zoom in. We factor by grouping. So here's these 2. And again, notice that's a plus sign. So we can actually just put grouping symbols here without messing anything up. All right, so what does that leave us? We still have a 2, and on the inside, what's common in those 2 terms? A 2x, right? And that leaves us a 2x minus 3. And if you do this right, you should be kind of seeing patterns. That is what we're trying to generate now in the next term. Well, 2x minus 3, there's really nothing in common again, so we'll just put a 1 there, and we get our 2x minus 3. So there it is. And now, on the inside, I have 2 terms, and they both have a common factor of 2x minus 3, so I'll factor it out, and that leaves me a 2x in the first term and a plus 1. And now we have linear factors. They're all x to the first, so we did it. It's a very systematic approach to factoring that way, okay? Very systematic. Every line, again, is equivalent to the line above and below. Now, let's go down that other fork. Because some of y'all, you know, addition is commutative. So it could very well work the other way. Let's say we split the middle term, and now we have 4x squared, but now we have plus 2x minus 6x minus 3. This one is going to cause a little bit more of a problem, possibly, if you're not diligent. So we're going to group these 2 together. Let me use a darker color. We're going to group these 2 together. And now notice, because that's a minus sign, not a plus sign, can I put a parenthesis between the minus sign and the 6 and do that? Is that still correct? No, it's not. Because by putting the parenthesis now between the negative and the 6, that's effectively factoring out the negative and not changing the second sign. So you can either change the sign of the second one, or you could do it this way, which is what I would kind of recommend. Put a parenthesis here and include the negative sign. But now what you want to do is like squeeze a plus sign in between there. Why? Because without squeezing a plus sign back in there, it looks like multiplication. All right, so be careful if that's a negative. Now look what we do. Same thing. Pull out a 2x, and you're left with 2x plus 1. And now we're going to factor out a -3. Remember, when your leading coefficient is negative, you always pull the negative sign out, and you're left with 2x plus 1. Close, close. So for every one you open, you should have one closed. And then, not surprisingly, we have a common factor of 2x plus 1. So we factor it out, and we're left with a 2x in the first term and a -3 in the second term. And notice it is equivalent. The only difference is because we grouped it the other way, on the left side, we were pulling out a 2x minus 3 factor, and on the right side, we were pulling out the common 2x plus 1 factor. But they're equivalent, okay? So there's no wrong way to eat a Reese's peanut butter cup. And there's no wrong way to do this problem correctly. How about that? But there is more than one way. Slow and steady wins the race. Inch by inch, it's a cinch. Be diligent, be deliberate. Stay focused, stay engaged. Okay. Cool. So now you have this this advanced factoring technique. You know that if you don't want to do guess and check, it's an algorithm. It systematically does it. Okay. All right. Let's look at letter G then. Letter G. G for gosh dang. Look at that one. It's written in descending order. That's good. Is there anything common other than 1 that we can factor out? Now here's the thing. I'm glad you said that. 6 is only a factor of the last number. This is crazy. We could factor out a 6. If you were heck bent on doing it, you can factor out a 6 because remember, factoring out is the same as dividing out. But that would leave you a 35/6 x squared minus a 1/6 x minus 2. Right? Verify. If you redistribute the 6, it's going to divide out in the first, divide out in the second. Do we want to do that? Have y'all ever factored with fractions? No. Yucky, yucky, gross, gross, right? Yucky, yucky, gross, gross. So this is not incorrect, but that's like bold. That's like eating like 10 ghost peppers back to back to back with nothing to drink, right? So can we do target product, target sum here? Do you want to? Okay, your target product is going to be 35 times negative 12. What the heck is that number? I don't know. Let's go off to the side. 35 times 12. That is, let's see, that's a 10. You carry the 1, you get 7. Add a 0. Oh, this is fun. I remember doing this. 5, 3. You add it together, you get 0, 2, 4. Hey, you get 420 again. Look at that. Snicker, snicker, giggle, giggle. 420. That's our target product, and our target sum is what? -1. Now look what we've created for ourselves now. I've got to find, bless you, 2 numbers that multiply to give me 420, that subtract or add to give me -1. 2 factors of 420 that only differ by 1 value. That's going to take a while to find, isn't it? It is -420. Thank you. Yes, it is -420. That would make a big difference. That might take a while to find. So even though this method will work, it's not always the best route, okay? So let's try and do this one by just guess and check, okay? We'll call this the Rio Grande Valley fly in your face, sweat on your desk method, okay? Here's what I'm going to do. I need to find combination of factors in 35 and 12 now that add up to -1. Now here's the deal. Because they have to add up to -1, their numbers are going to have, the factors are going to have to be pretty close to each other. So for 35, do I want to choose 35 and 1? No, those are too far apart from each other. If the middle term was actually a big number, now you want your factors to be farther apart. So are there any other factors of 35 than 35 and 1? 5 and 7. Yeah, so I'm going to call this one 5x and 7x. And it doesn't matter if you call it 7x and 5x. 5 and 7 are relatively close together. Yeah. Now, what matters is how you pair them up. 12, let's see. You think we're going to use a 12-1 combo on the 12? No. Does it have any factors that are closer together? 2 and 6? 4 and 3. Okay. So now we have really only 2 options. Either the 4 is going to be here and the 3 is going to be there, or the 3 is going to be here and the 4 is going to be there, right? Let's just see. If it's a 4-3 combo, that gives us a 28 on the inside and a 15 on the outside. Do 28 and 15 differ by 1 value? No. So it's probably not going to be the that combo. It's not going to be the 4-3. Maybe it's the old 3-4 combo. 3 times 7 is 21. 5 times 4 is 20. They differ by 1. Hey, we got it. So now we'll get rid of that, and we'll write 3 and 4 more prominently, more boldly. And now all we have to do is work on the SIGN sign. I want the middle term to be negative, so the larger product has to be negative, which is what, 21 or 20? 21. So this has to be a -3 and a +4. We did it. We did it. We did it. Yeah, lo hicimos, right? And we didn't even have to use the whatever, target sum, target product, split the middle term method. So not every tool is going to be used for every job, right? But if all you have is a hammer, then you got to make every single problem you encounter look like a nail. And that's kind of hard to do, right? So we have different tools for different things, right? You want to size up the problem, which tool does the job in this case? Now, just for kicks and giggles, kind of a preview of coming attractions, the reason that we're so interested in factoring is because we're trying to eventually solve equations. And if I can factor that polynomial, I can now set it equal to 0. Let's just say I set it equal to 0. It's not right now, but this will be like an extra example. Now I can say, oh, 5x minus 3 equals 0, or 7x plus 4 equals 0. It only works when it's factored and equals 0. So then you got x equals 3/5, or x equals negative 4/7. And now you have possibly two solutions that answer the question that you set out to answer. So that's why factoring is so important. In fact, in this class, you know, if we look at an expression and we're frustrated and we say, F it, you know what that means in here? Factor it. Yeah, factor is the F word in here. All right, so anyway, we don't do that. If we're working with expressions, they're not equations. Don't just arbitrarily factor an expression and then set it equal to 0 and solve. Okay, don't do that. Right now, we're just practicing with the expressions. All right, any comments on that one? All righty, moving on. How are we doing on time? Oh, we got plenty of time. Heck yeah. Oh boy. What's different about this one? Yeah, it's a 4-term polynomial. So we don't call that like a quatrinomial. We say it's a 4-term polynomial. This is the first one that we've seen that actually has 4 terms. We have generated 4 terms by splitting the middle term. This one starts off as 4 terms. And it appears to be written in descending order, which is called standard form. So nothing really to do to set the table. So guess how we're going to do this one? Factoring it by grouping. Yeah, factor by grouping. So descending order, so we're going to have that. And now notice again, I have to be cuidado, right? I got to put a parenthesis here and sneak a plus sign in there, okay? I will look at all your intermediate steps on any assessment. And if you fail to put that plus sign there, if it's not equivalent, you'll lose points. So details matter. Okay, that's really when it's a negative sign. Now, what do we factor out of the first one? X squared, and that leaves us 3x plus 1. And now again, if you figured out how factor by grouping work, that is what we're trying to now accomplish in the second set. So let's see if we can get that. We factor out a negative 2, and that does leave us a positive 3x plus 1. So now I have 2 terms. I'll factor out the 3x plus 1, and that leaves me with x squared in the first and minus 2 in the second. Are we Brooks and Dunn right now? Is this it? Is this as far as we go? Yeah, let's talk about x squared minus 2. It's not linear, right? 3x plus 1 is linear, x to the first. But if you have a quadratic factor, you might want to see if it does factor. Now, if that were x squared plus 2, it wouldn't factor. It'd be irreducible. So believe it or not, x squared minus 2 is considered a difference of squares. It's just not a difference of 2 perfect squares, okay? So it should factor into the product of 2 whatchages? Conjugates. All right, let's do that. So we have a 3x plus 1, and we got something times something, something times something. The square root of x squared is x. What's the square root of 2? Is it a perfect square? No. So the square root of 2 is just the square root of 2. Jawohl. Plus minus. Now remember, the square root of 2 has that distinction of being really the only known number for which a mathematician lost his life. Right? Remember, did I tell you the story of Hypasus? Yeah, poor guy. They tell you that as they threw him over, they added insult to injury. His name was Hypasus. And as he was going down, they went, bye, Passus, instead of Hypasus. And he was like, that's not funny. Poor guy. So this is an irrational number. This is it. Now, really, if this were a short answer, I would accept either one of those, okay? I would accept either one of those. Because remember, the goal is to set it equal to 0. And it's just as easy to set x squared minus 2 equal to 0 and solve by extracting square roots rather than to factor it and set each factor equal to 0. So they're both good. Like a Crunchwrap Supreme. Good to go. Okay. All right. Moving right along here. Take a look at I. Letter I. What's different about this one? What? Yeah, it looks like it's not totally expanded, right? So we can't say like it's a cubic polynomial. It does look like it has 2 terms, doesn't it? 2 terms, each with some complex factor groups. So here's this term, and here's this term. Okay, so this one we say is partially factored. Now there's 2 ways to set out about how to do this. You could just walk up with your giant sledgehammer without thinking and just start swinging at it, right? That would mean expand it out. Do we want to expand it out, distribute, and FOIL? Remember, our goal is to get it factored. And if you expand or distribute, FOIL, you're going in the wrong direction, which sometimes it might be the option. Because once you expand it out, you might be able to collect like terms, write it in descending order, and then reassess and do anything we've done so far. But here's the thing. If something is partially factored, what you want to do is not expand it out. You always want to, again, look for GCF first. If it's partially factored, it might already be part of the way towards what we want. So that's still the first rule of factoring. Look for a common factor. Is there anything common in the 2 terms other than 1, though? I can't factor out the x squared because it's part of that second, it's part of a factor group in the second term. So I don't really see anything common to factor out. But is there anything we could factor out from either one of them? 10x minus 4, like for lack of not having anything else to do, what could I factor out of 10x minus 4? A 2, right? Let's see what that looks like. So the first one is just x squared. This is 5x minus 2. Now, when you factor a 2 out of here, you can actually bring it to the front of that factor group because multiplication is associative. So that becomes 5x minus 2. Oh, and now what happens? You hear a little bell ringing, right? Ding, 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 ding. Because what do you notice now? 5x minus 2 is now a common binomial factor in both terms. Oh, okay. So let's factor out the 5x minus 2. And then parentheses, what are we left in the first term? X squared, right? Plus 2 times this junk. Close, close. So now it's factored, right? The first one is linear. The second one looks like it could be cleaned up a little bit, all right? So instead of expanding in the very beginning, we found a common factor. Now it's time to expand that one because it's ugly and see if we can't combine like terms. But we don't expand first. So if we distribute the 2, we get plus 6x squared minus 2. And then we bring down the factor. And now what happens on the second factor? We end up with 7x squared minus 2. And that's pretty, okay? That original expression is equal to every single one of those lines above and below. Now, is that all the way? Or is there something else we could do? Is 7x squared minus 2 a difference in squares? Yeah, remember, they don't have to be perfect squares. Y'all are used to seeing perfect squares, like 9x squared minus 4, right, by design. They don't have to be perfect squares. If it's a difference and it's quadratic, it could factor. So here's what it would be. Something times something times something times something. One of them's plus, one of them's minus. Those are what you get of each other? Conjugates. Okay. The square root of 7x squared is the square root of 7x. Now, when you write that, make sure that the radical only goes over the 7 and the x is outside. And then plus or minus, what's the square root of 2? Square root of 2. Once again, I would accept either one of these as a short answer, as a final answer. The bottom one technically is factored all the way into its prime factors, but it's yucky, yucky, gross, gross, right? You'll see that when it comes time to solve, we almost prefer solving the second to last line instead of the bottom line. And if that's our goal, it's really good that we just make you aware of this other version, but not necessarily require you to do it. Right? Like I'm aware that I could skip class and go into Panther Canyon and go find my little like ammo box that's in Panther Canyon and open it up, and inside that's where I keep my math stash, and I can sit in the canyon and do math, right, and skip school. I'm aware of that, but I'm not going to do that. It's yucky, yucky, gross, gross. Right? That used to be a real big problem. Hello, Mr. Garcia. Good morning. Happy National Skyscraper Day. Hey, let's celebrate together on count of 3. Just scrape the sky. Ready? 1, 2, 3. Yeah, baby. Good times. Yep, yep, yep. Mr. Garcia. It's hard for me to sit in the corner. Really hard. Really hard. Because I'm usually a float around the room kind of guy. So I'm trying from over here, but anyway. How are we doing on time? We got time for one more? 30 minutes. Oh, crap. Okay. Well, here's the good news. We finished example 1. It only took us an hour. Any questions on that? It's so important that we get all these fundamental things that you previously learned down pat, because as we move forward, it's going to build. It's going to build. Okay. Okay. 30 minutes left. So what I'll do at this point is I think I'll stop. Okay. And I will give you the rest of the class, which is 30 minutes to do one of several things, right? You can work on submitting any one of those 4 assignments that's due tomorrow by 8:50. That's the notes from 1.1, which should be done. The homework multiple choice, the homework short answer, and then the other quiz. If you've submitted all of those, feel free to jump in and start doing 1.2. Now, I would say do the multiple choice from 1.2 first, because the short answer from 1.2 gets into solving equations, which is where we're stopping today. But you should be able to do the multiple choice. There's a lot of simplifying expressions, okay? So not often are we going to get, class time to do work in here, unfortunately, because we do have to keep moving. But you know what? This is the end of 2 weeks, and I think everyone's feeling a little fatigued. I wish we had like a 3-day weekend or something coming up. That'd be nice to recuperate. Yeah, okay. All right, so any questions then? 30 minutes, be productive. If you have your own music, you want to plug in quietly, it's not disturbing anybody, that's fine. You can do that. You can collaborate with each other during this time, which is not copying. Collaboration means you bounce ideas off each other. Everyone walks away with the knowledge from that session, okay? On your marks, get sets, go.